So today we're going to talk about something called ionic compounds. Covalent compounds. We already did ionic. We're going to talk about something called covalent compounds, or your book calls them molecular compounds. Okay? So these are covalent / molecular compounds. Okay, I always call them covalent compounds because they share electrons, and we're going to get to that bonding section next semester, but your book does call them molecular compounds, so those two terms are interchangeable. Okay, these are covalent compounds, and covalent compounds are made up of two nonmetals. Where ionic compounds were a metal and a nonmetal, covalent compounds are made up of two nonmetals. That means both of our elements are coming from which side of the periodic table? The right. And that means they're both what type of charge? They're both negatively charged. Okay, so these molecules, these covalent molecules don't give us an overall neutral charge. Right? The charges don't have an effect on covalent molecules because we're putting two negatives together. Okay, so we're not concerned about the charge of these molecules. We're just going to name them exactly as they are shown. Okay, so these are a little simpler to name than ionic compounds are. Okay, but these are two nonmetals. So what happens in these two nonmetals is that they share electrons. Okay, they share their electrons. They don't give them up. They don't transfer them like ionic compounds do. Again, we'll cover that bonding, ionic and covalent bonds in Chapter 6, which we'll do next semester. But that's what happens in a covalent compound and a covalent bond, is that they share their electrons. Okay? So in order to start naming these covalent compounds, we use some Greek prefixes. So I need you to turn to page 228 in your book. So copy down these prefixes. Page 228. And there is a table 3 on page 228 that you need to have copied down. Okay, and that prefixes. So 1 has a prefix of mono, 2 has a prefix of di. That whole table right there with numerical prefixes, you need to have that down in your notes. And you will need to start to memorize those prefixes. So when we name covalent compounds, we're looking at compounds that are between two nonmetals. So our compounds are most of the time made up of carbon, nitrogen, oxygen, phosphorus, sulfur, those types of molecules, okay? So here's a couple examples of covalent compounds that you might be familiar with. What are the names of those molecules? What's the name of that first molecule? Do we know it? Yeah. Okay. Carbon dioxide. And we've heard of it. It's a very, very common compound. Do we know the name of the second molecule? Carbon monoxide. Do we notice those prefixes that we just wrote down? Di here and mono here. Okay, so these compounds that we've known the name of for a long time follow these rules for naming. Okay, we've known they've been called carbon dioxide. We didn't know why. Okay, this is a covalent compound, and this is how we go about naming them. Okay, so we're going to look at these as examples. You can think of these as examples, but I'm going to walk you through the rules that we follow for covalent naming. Okay, so always between two nonmetals. So when you see a compound, the first thing that you have to do is decide, is it an ionic compound or is it a covalent compound? From there, that determines the rules you follow for naming, right? Ionic compounds are between a metal and a nonmetal. The anion gets an IDE, or a polyatomic ion gets to keep its name. Whereas when you're dealing with covalent compounds, they follow a different set of rules. Okay, so let's walk through the rules for covalent naming. Okay, so these are rules for covalent naming. Okay, number 1, how do we decide which of our anions or which of our nonmetals gets to go first? Okay, why is it not dioxygen carbide, right? Why is it not O2C? Why is it CO2? Okay, so our first rule for covalent naming is that the element with the smaller group number gets listed first. Okay, so the element with the smaller group number, or that's the element farthest to the left. It gets to go first. So, does carbon have a smaller group number than oxygen? Yes, that's why it gets to go first. Okay, carbon is listed before the oxygen. Okay, yeah.